There we go. Thank you. Yeah. Okay, this presentation was written on Monday, and since then, two very important reports have come out, and they'll probably be on your briefing note tomorrow morning from the UK Energy Research Centre. And both of those reports tend to support things I'm going to say anyway, so I'm quite pleased I've aligned quite well with their sentiments. The UK has a hydrocarbon system. And it's certainly been known since Roman times, and it's probably been known since Bronze Age times. Noah used pitch to make his ark waterproof, and we know that coracles use pitch, etc., etc. And this is in the Peak District National Park, where you're not allowed to drill or frack. And there is oil coming to surface here, top of this cliff here. And it's overlooked by a Bronze Age camp on the top of Mam Tor. I'm sure that the juxtaposition of those two sites is no coincidence. This would have been a valuable substance to the Bronze Age community. It comes to the surface. It's an open access area. There's no skull and crossbones there. No, toxic hazard. Keep away. Don't eat the sheep that graze here, etc., etc. So I just want to put in context that hydrocarbons come to the surface naturally, and providing they're coming at a rate that the environment can cope with, they're not a problem. So the British Geological Survey was commissioned by the Department of Energy and Climate Change to look at, first of all, the shale gas resource. And there's a very big difference between the term resource and reserve. I'm not talking about reserves at all. There are no proven reserves of shale gas in the UK, okay? But we do have a resource, there's no doubt about that. And this first report was for northern and central England. Don't have a pointer, do we? Do we have a pointer? How do I work that? I press that? Yeah, here we go. So this really is from the coalfields of the Midlands, the Warwickshire coalfield, Leicestershire coalfield, Notts, Derby coalfield, right up through the Lancashire coalfield up to about Lancaster on that side, and up through the Lincolnshire coalfield up to the North York Moors on that side of the country. That was the area that DEC wanted us to look at. And it was just the interval of shales known as the Bowl and Hodder. I did my PhD on those shales a long time ago, grew up on them. I'm from the northwest of England. And we were only asked to look at the shale gas, the methane. There is actually a lot of shale oil here. We weren't asked to look at that. I don't know why. I wasn't involved in the negotiations. But this report, many of you will be familiar with, came out in 2013, and it had a medium gas in place. That's gas in the rock. Doesn't mean to say you can get it out. But gas contained in the rock, a median estimate of that, which is a huge figure. Of course, many of this, we've already got national parks, many of these areas are conurbations, so just geographically there won't be access to all that resource. And then we actually have to drill and test where we can drill and see whether we can get it to produce gas to surface. And so far, we've only had one frack test in 2011. It wasn't a full test, and since then, nothing. So we're not getting on with exploration very fast, are we? A second report came out this year, and this was for the Weald Basin down here. I had a very unpleasant public meeting down there earlier this year, which was a typical example of how the regional media mishandle things. But anyway, what this did show was there was no shale gas onshore here, but there was a shale oil resource. And that was the estimate they gave. Again, you don't know whether you can get it out. And shortly afterwards, in June, came another study, and this was for the Carboniferous rocks. These are Mesozoic rocks down here. The shale is mainly in the Jurassic, which is the main system for the dinosaurs. This again was back in the Carboniferous up here. And interesting, this is the first place we actually produced oil from Carboniferous rocks at large scale in 1851 from oil shales. And that's why Grangemouth Refinery is there. It's also where all the basic science of refining was developed. I'd like to think there might have been a crossover from the whiskey distilling industry into oil. I'm sure there must have been. And So, you know, there were ever more sophisticated ways of getting the oil out of the shale and fractionating it into all sorts of products you now know. But that industry declined dramatically after World War I because we started to get oil from the Middle East. Okay, just to put things in context, UK primary oil production in 2012 was about 50 million tonnes. Oil products consumption used 76 million tonnes, okay? And those are the oil in place just for the Midland Valley of Scotland. So I don't know why DEC was quite happy to look at shale oil here, was happy to look at shale oil here, but didn't commission it for here. I've no idea. Seems irrational. There is a lot of shale oil in this area. I submitted a 17.5 kilo block of shale to Leicester University to their latest Gizmo. It's one of the big NERC infrastructure laboratories for identifying organic compounds, and they found over 100 non-methane compounds in that shale. All of them, you know, could be of commercial value. So why do we have all this oil and gas in the Carboniferous in Britain? Well, that's all down to geology. And the world was a very different place in the Carboniferous. We were virtually on the equator, just south of it, in those little green dots, that cluster there. There was no Atlantic. Greenland was attached to Scandinavia and Scotland. And actually, the Scots were given the chance to leave us during the sort of late Cretaceous, early Paleocene, and they didn't. So, you know, they voted with their feet back then. In fact, we even took a bit of North America with us, which is why you have the lovely Durness limestone, the Torridonian sandstone up in northwest Scotland, and the Louisian gneisses and things. But anyway, there was an ocean to the south of us, and that's closed. That began to close in the Carboniferous, and by the end of the Carboniferous, it completely closed. But that ocean subducted beneath our own continental plate, and the remains of that ocean are hardly any left at all. But if you go to the Lizard, that's why you have the serpentinites there at the Lizard. That is the metamorphosed deep ocean floor that had been buried deep down and changed to serpentinite. It's quite a rare rock in a global scheme of things. So just think about that next time you're down in the Lizard. That subduction pulled the crust to the north towards it and stretched it. So that meant the crust pulled apart, and we ended up with these basins, the big faults going down deep into the earth, and the earth was pulled apart. That then meant the land sank, and that then meant that that land could accommodate sediment. And that's why we have these thick sequences in our Carboniferous. Plus, whoops, didn't want to do that. Greenland was oh dear me. Greenland was, what am I pressing? Here. East Greenland was tectonically very active, and it was in this sort of semi-arid zone up here. Now, semi-arid erosion is very rapid because there isn't much vegetational cover, and it's flash flooded. And these were mountain ranges. And so a lot of sediment came down towards Britain from East Greenland and also went north up further into the present-day Arctic. And it's these huge river systems, and we're talking big, big rivers that carried tons of sediment, that brought the clays and the sands down into Britain and progressively filled these rift basins from north to south. So the Scottish one gets filled first, then the Solway, Northumberland one, and then the basin, the Pennine basins down here get filled last. There's a progressive filling. But in advance of those deltas that filled those basins, we get a lot of shale deposition. And it's those shales which trap the organic remains that were being washed down the rivers and the plankton that were living in relatively deep seawater here. And the water was layered, so the seabed was starved of oxygen, which meant that organic remains accumulated rather like they do presently on the floor of the Black Sea or the floor of the Baltic. So that's why we have these shales, and we know these shales have source rocks for many of our onshore oil fields. I'll talk to you later about that, and some of our offshore ones. So a very different world. It's also the time for the first widespread equatorial rainforests. CO2 was plummeting. Climate was getting colder all the time through the Carboniferous, and there was a major ice age started in the middle of the Carboniferous. Atmospheric oxygen levels were much higher than today. and there were no calcareous microplankton. That also means that when you get shale deposition, it's not going to be diluted by chalk. So you don't get chalks in rocks this age. So, 10 meters of shale here would be hundreds of meters of chalk later on when the calcareous microplankton evolved at the time of the dinosaurs. So the whole geochemistry of the oceans changed during the Mesozoic, during the period of the dinosaurs, compared to these old Paleozoic oceans. Okay. I've got to tell you about geology because it's a wonderful subject, so I hope I'm not boring you and I'm trying to get it across just so you get a flavour of things. Anyway, in that deck report for the Central Pennines, here you can see on this diagram these basins, the blue areas here and the main faults. So that oil seep I showed you is just there, just south of the Edale Basin. This is where Quadrilla have drilled these really 3 wells and managed to part frac test one. And there's been an IGAS have drilled very recently somewhere down here as well, but only a stratigraphic well. They didn't do any fracking. I live here in the Widmerpool Trough, and I have an oil field behind my house that's produced 250,000 barrels of oil from these shales, from sandstones within these shales. And in fact, the East Midlands area here is where all the onshore oil and gas development really developed just before World War II, conventional oil and gas, and we'll go on to that in a minute. But look at this column here. That's the scale, and remember these scales for when we go to the next slide. But that there is 100 meters, I think. Anyway, this section here is Long Eaton number 1. That's an almost continuous shale section. It was a borehole drilled next to Radcliffe-on-Soar Power Station. If any of you use East Midlands Parkway Railway Station, that's that big power plant there. That's the second largest emitter of CO2 in the country. It also consumes a lot of Derbyshire's limestone to scrub the sulphur out of the coal it burns. So you can imagine, and when people calculate emissions from coal-fired power burning, they never seem to factor in the limestone that's used. I wish they would. Just imagine if we could produce from this shale here, this thick shale sequence, which is very close to that power plant, and convert that power plant to gas, we'd halve the emissions straight away. So this is the, for me, because I am not a climate change denier, I believe it's absolutely essential we go down a low emission trajectory. But I see gas as a very important part of that. And if we have the benefit of producing our own gas, why not? Okay. But just think of these thicknesses here. This, that's just a borehole. This section, there's another long one. Plantation Farm anticline there. Base not seen at surface, Boland Basin. Here we have over 3 kilometres of shales. Okay, it's not been shown here because they just couldn't fit it on the diagram. And all this stuff goes out under the Irish Sea, the East Irish Sea. This is why we have oil and gas fields in this area. We have oil seeps to surface at Formby, into the groundwater there, where we have natterjack toads and red squirrels. I don't think anyone's banned from going on the beach, and the natterjack toads and the red squirrels aren't dying out because of it. These are natural seeps. There are seeps within the city of Liverpool in railway cuttings. So, oil seeps to the surface in conurbations. So I think there is a lot of hysteria about oil leakage and stuff getting to the surface from the anti-frack people, to be honest. Right. So let's have a look at shales of the same age in America. And this is a very, very successful unit of shales for producing shale gas in America. The Barnett is where it was all pioneered, actually. So this is the same interval of geological time. And I was telling you we had kilometres thickness of shale. And you could, look at the scale here on this. So that's 60 metres there. So we're talking about 200 metres maximum thickness of those shales. So when we drill in this country, and if we find that the shales will produce, theoretically we have a much bigger access of volume of shale per well pad than you would have in America. Because here you've just got to move laterally all the time to keep, getting at shale that you haven't produced from. Whereas we would have, hopefully, lots of stacked seams of shales over great thicknesses. So that's the sort of juicy aspect between the US and us, although the US is a much bigger country, obviously, and they're much more geared up to drilling We don't have the rig capacity in this country to get anything like the pace the US are at the moment. The other thing is that although we have very thick shale sections here, here's that plantation farm thing again, and there's loads of top section missing. This is a paper I published in 1990. This just shows you some of the organisms that occur in the shales in some gravity slides. And shales are very varied rocks, so there's all sorts of other rocks in there within the shaly sequence. And it's all these different types of rocks that are coming into this deep water basin through different gateways from different mechanisms, and this is all stuff transported in here. It's too much detail to tell you tonight, but all this affects the mechanical properties of the shale and the organic content of the shale. The mechanical properties are very important for fracking because you want a brittle rock. And so we have a very good understanding in the Boland Basin. This is all from my PhD thesis that I published way back in 1990. But just look at the difference between the American scenario, where we don't have great variations in thickness laterally, but it seems to be much more layer cake, to what we have. We have huge changes laterally in thickness. So that's another difference we have. And this is obviously, going to be something that explorers need to understand and be able to predict where the thickest sequences are and where the sequences are likely to be with rock types which have the right mechanical properties as well as hold the gas, otherwise they won't frack. When we look at our Carboniferous rocks, I told you about this glaciation, the climate's getting colder, so by the time the Millstone Grit was being laid down, that's the rocks of the Dark Peak in the Pennines, sea level was bouncing up and down regularly like it is now. We are in an ice age now, we're just in an interglacial. Well, this was happening in the Carboniferous, and my forebears, Wright et al. In the Geological Survey, worked this out before World War I. In fact, this was the very first sea level curve ever produced that I'm aware of that really accurately portrays and still stands today for this sequence. This is in the Rosendale area of central Lancashire. They couldn't publish till 1927 because World War I delayed all the publishing, and they were taken off this work, obviously for the war effort, to concentrate on coal production. But this well here is a wildcat well just south of Lancaster, and you can see the same signatures just measuring the natural radioactivity of the rocks. So the marine shales have a higher radioactivity than the sandstones that are coming down this river system. And as sea level rose and fell, the sands would advance and recede, and the shales would advance and recede. So you see these signatures. So this is, one of the key things in an exploration well is to understand which layer you're dealing with, and you need to core. This well was drilled in the 1960s, wasn't cored at all. And you can see these marine deposits, the transgression on the tops of these deltas, outcrop, again near Lancaster, and you can see these beautiful beach deposits here with lugworm burrows and wave ripples, and there are tidal gutters. It's just like walking on the beach. You can go 15 miles from here and see a beach today at Morecambe, just the same as this, except this is 335 million years old. And then the shales, when the sea level gets higher and moves further inland, and this deposition is replaced by shales, are all in the far bank there. So that you're seeing one of these parts of these marine cycles here. This actually was an analogue I used in the 1990s for a tight gas reservoir in the Trent field in the southern North Sea, which is fracked and produces gas to this day, I still think. It's Arco-British discovered it. So I was involved in the early exploration, early development of that. So there's a lot of concern about well integrity, and there's a project funded by the research councils and by industry, but industry have no say in what the project does, which is hosted by Durham University, Davies et al., and they're producing papers, looking at, well, what are the risks of leakage through the infrastructure for oil and gas wells. And they didn't cover this in their paper. I was a bit surprised they didn't. But what they did say was of 143 active onshore wells that were producing at the end of 2000, one has evidence of a well integrity failure. That doesn't tell you that it's poisoned everything, it's just telling you the well has failed in some way. But if you go to the Environment Agency website, for the East Midlands, and all those red dots there, we have the highest density of oil and gas wells and coal exploration wells going back 100 years. Tibbs Shelf Services was the first conventional oil exploration well drilled onshore UK. You find that pollution incidents to water, which are in the Environment Agency regional statistics for the East Midlands, the last set I could get, which are 2009, there's nothing in here for oil and gas at all. These are all reported incidents, but it's actually the water industry itself, the service sector, and agriculture, which are the worst offenders. Just getting these things in context. The British Geological Survey, the Environment Agency have been working together, and they've been doing sampling of water wells throughout Britain, particularly in potential shale gas areas. Every water sample has natural methane in it, okay? And we get methane, that's my photograph to the right. I discovered that in the 1970s. I've been trying to get people to work on it ever since, and no one has. But here we see gas seeping from groundwater into the River Hodder, which is a salmon trout river. Again, no, it's only a few metres from a public footpath, and you're not banned from fishing or eating the fish from there or anything like that. There's a lot being said now by the anti-frack people about health effects, etc., but they're very difficult to verify because you need a baseline. Thankfully, we have a baseline in the UK. This came out this year, and it's very, very cautious about looking at the epidemiology of various diseases, both across the genders and across age ranges and geographically. It's very cautious about, can we see linkages between particular industrial activities, natural environmental sources, as well as anthropogenic. And it takes 20 years of data mining at ward level, election ward level, to do that. So this is the most sophisticated baseline database of a population there is. So when frackers say, I know 7 people who've got cancer near a Pennsylvania frack well, therefore fracking causes cancer, you need to point them to this. That's the sort of study you need to do to verify those sort of relationships. The earthquake was the reason, we called it an earthquake, it's actually an earth tremor, that the fracking stopped in 2011, and you mentioned that I know industry thinks it's too tight, there's some of the monitoring and requirements now for that. But just to put things in context, there will be seismic events that this building is now feeling from tube trains under London. And you can go to, I go to Piccadilly a lot, and the Geological Society is there. I can tell you every 3 or 4 minutes when there's a tube train, nobody bothers about it. Some of the most expensive real estate in the world, some of the most valuable buildings, some valuable art collections, blah, blah, blah. So get things in context, please. The Blackpool earthquake was felt by 50 people, only just felt. It did no damage whatsoever. And we talked about sustainability. Certainly the Committee on Climate Change see a transition role for shale gas if we can produce it in the UK. It doesn't mean we won't reach our target. And this is an independent committee. It's independent of government. Right. Will we be able to get shale gas quickly in this country? Well, I told you, we're just not exploring fast enough. We're actually somewhere down here on this graph. And this means that unless we get drilling and fracking and doing these tests, we're never going to even get into this bit. So again, covering the landscape with wells and all the fear and alarm, and also the over-exaggeration of what impact shale gas will have on our own gas prices if we can produce it in the UK. These are all very premature arguments. Let's get exploring, drilling and fracking. Then we know, where can we produce? And that's when we have the debate. Then do we go ahead and produce, when we can home in on where we do it. The Geological Survey Directors of Europe issued this month, in October, and they said they are very concerned about the media and the campaigners really driving the agenda of information. And there's so much misinformation. Some of it is because they obviously don't understand. Some of it is deliberate misinformation. This film here, Gaslands, is probably the worst offender. The person making the film knew that was nothing to do with fracking. That's natural methane contamination in his well. It's nothing to do with fracking. Yet, how often do you see that on the TV shown every time there's a frack article on the telly? The problem is that there's lots of underground technologies that we really need in our country to actually deliver renewables and to deal with our nuclear waste problem. And that, and we have to deal with that nuclear waste. It's there, it's not going to go away, just leaving it on the surface and being paralysed what to do with it. But renewable technologies need big energy storage facilities, and the geology, the subsurface geology of this country is going to be absolutely vital if renewables are going to make the impact that they have to make to get our emission trajectory down. And our shale gas infrastructure, if it does happen, could be a really good source of infrastructure for biogas and for geothermal. So think about it. You know, we need to be creative. There's this polarisation of the argument is not helping, and the misinformation and the campaigning particularly, which, you know, is what I believe has held things up. And that's my last slide, and I'm a scientist, so I like evidence-based reason. Thank you. Sorry I overshot slightly.